Black holes are some of the weirdest, most mysterious objects in the universe. It might be better not to think of them as objects at all. A black hole is a region of space where matter is crunched so tightly and warps space so intensely that nothing can escape its invisible boundary, not even light. Any sufficiently large clump of matter could form a black hole if you squished it enough. But unlike the amazing diversity of other types of matter, making up the planets, stars, and galaxies that pepper the universe, black holes are all kind of the same. The main thing that sets one black hole apart from another is its mass. Black holes with different masses behave differently from each other, and we detect them in different ways. You can think of them as different flavors of black holes. Here's how they work. Stellar mass black holes are the collapsed cores of giant stars. They form after massive stars explode in supernovas, marking the star's final phase of life. Stellar mass black holes have masses up to a few tens that of the Sun. They're the most common type of black hole, and they're scattered throughout the Milky Way and other galaxies. The first black hole ever discovered is one of this flavor. In 1971, astronomers realized that bright X-rays spewing from a source called Cygnus X1 came from a black hole stealing matter from a companion star. Another way to find stellar mass black holes is to observe how their extreme gravity warps the light from more distant stars behind them. That's a process called gravitational microlensing. But you don't always need light to find stellar mass black holes. Ground-based observatories have detected gravitational waves, or ripples in spacetime, coming from pairs of black holes. These waves are cast off as the two black holes spiral around each other and merge into a single black hole. Supermassive black holes are the heftiest black holes in the universe, weighing in at millions to billions of times the mass of the Sun. Pretty much every large galaxy is anchored by a supermassive black hole at its center. The first sign of these gargantuan black holes came in 1963 with the discovery of quasars. The word quasar comes from quasi-stellar because at first astronomers thought they were bright stars. But they're actually extremely distant objects that are so bright they outshine all the stars in their entire galaxy. Later studies show that the bright parts of quasars are disks of white-hot gas and plasma that swirl around the supermassive black hole like water circling a drain. Astronomers have also detected supermassive black holes by watching stars zipping around the central region of a galaxy. The star's speeds and trajectories make sense only if there's a huge unseen mass there. This technique backed up the existence of the black hole in the galaxy M87 and the black hole at the center of the Milky Way. Scientists have even taken pictures of supermassive black holes. A network of radio telescopes around the world banded together to form the Event Horizon Telescope, with the array acting like a single eye on the sky. The collected effort let them make images of the disk around the supermassive black holes in M87 and in the Milky Way. How supermassive black holes form is unknown. There are supposed to be physical limits on how quickly a black hole can gobble up matter, which limits how fast it can grow. But observations of quasars in the early universe have found black holes that seem too big to exist at the time we see them. How they got so big so fast is a mystery. Intermediate mass black holes are the middleweights of the black hole crew. Their masses fall in between the smaller stellar mass and bigger supermassive black holes. They range from hundreds to thousands of solar masses. But they're rare beasts, and we don't know much about them. There are only a few confirmed candidates, and whether they're truly intermediate mass black holes or something masquerading as a black hole is hotly debated. We also don't understand how they formed. Were they born as stellar mass black holes that grew by merging with other similarly sized black holes? Are they so hard to find because most of them have already glommed onto supermassive black holes? Could they help explain how supermassive black holes got so big so fast? These are just some of the unknowns about this flavor of black hole. Primordial black holes are perhaps the most mysterious of all black holes. We don't even know if they exist, though theories suggest they may be out there. Unlike the other black holes, which need stars and galaxies to form, primordial black holes might have been born out of fluctuations in the fabric of the early universe, before the first stars even appeared. Astronomers are actively working on ways to detect these early arrivals. If they exist, they could help answer the mystery of dark matter. Dark matter is the elusive substance that makes up most of the matter in the universe, but emits no light of its own. Scientists can see dark matter's influence on regular matter, but don't know what it is. Maybe at least some of it is primordial black holes. Gaining a deeper understanding of these different types of black holes could unlock some of the universe's greatest mysteries, like the earliest moments of the universe or the interface between gravity and quantum physics. Black holes aren't just cosmic voids, they're a window into the unknown.